I thought it would be helpful to make a video comparing a conventional action in with the Hickman action to point out some significant differences. Here we have a conventional action, and I think the point we want to make here is that in most conventional actions, there are a number of lead weights that get put into the key in order to balance this whole system. In this particular case, we have note 15, and out of 132 grams for the entire key, 71 of those are in lead weights. Now, why is it important when the key is balanced? Well, the additional mass that's put into this lead weight means that it's not as responsive to the input of the artist's touch. And so that has a significant impact in terms of the way this action feels. And why am I bringing this up? Well, because there are no lead weights in any keys on the Hickman action. When we go over to the components that I had made, I'll call the lower leg. This is the upper leg. This is the driven member, which is composed of two components with their grains oriented in such a way that to deal with the forces. There is a tongue and groove arrangement here that is permanently glued in place so they become one piece. And of course, this is the flange. When we go to take a look at the finished components, which I'm showing here, I guess what I'd say is that when the artist plays the key, that causes the capstan to move up and impart the forces into the lower leg and the upper leg. The capstan and this clip are a little bit different in terms of their arrangement. The capstan has got a groove and is pointed, and the clip has got two fingers that go into the groove, and there's also a small dent there that helps the capstan and the clip stay together through the point going into that dent. This is what's commonly referred to as an over-center joint. So what that means is if you were to draw a straight line from this particular pin down to this particular pin, this joint location would be to the right of that center line. As long as it remains to the right, this moves up and acts as one member. Now, when the key is depressed and the capstan moves up, there's two things that occur. This driven member now starts to rotate around the flange at this point right here through the forces exerted through the upper leg, and that causes the hammer shank and the hammer to start moving towards the string. In addition to that, this leg here starts to rotate towards these two pieces. This particular screw is what I call the kick-out screw, and what that does is at a precise moment, it actually moves that upper leg past the center line and over center, thus allowing this joint to collapse. And once it's collapsed, no additional force that's put into the lower leg will drive this member in rotation. This particular screw is what I call the stop rail screw, and its purpose is to actually stop the momentum of the driven member. There is a piece that's not shown here. It's called the stop rail. It runs the length of the keyboard, and you can adjust these. These are obviously individually adjustable for each particular note. The repetition spring is this item right here. The lower end of the spring goes into this particular hole. The upper end goes into one of four holes here. And it really would be dependent upon where this particular note is on the keyboard. So the lighter, in the treble end, it would go into this particular hole right here. And once it's in that hole, the compression of the spring provides about 15 grams of force. And as you go and have successfully heavier hammers, you're going to be moving this particular spring location into one of these holes. And that gives you around 4 to 5 grams at each hole as you move towards this direction. The other thing that's interesting to note is that this lower part of the spring is bent, and that allows you, it's kind of at a 45-degree angle. And what you can do with that is that gives you an additional fine tuning, the ability to fine tune that spring force by either straightening the spring to increase the force, or by making this more of a 90-degree angle spring, and then that way it doesn't have as big of a, has a bigger angle. So that's how that operates. One thing I'll point out here is that this joint is under a lot of stress. So, I've located some material. It's a composite resin material. It's impregnated with graphite, and that helps for lubrication of that particular joint. It's also got a medium cotton weave in it, and that helps it for strength and stability. If we go down to the touch weight compensation system, these are the components that are really acting on each individual key. Now there's a lever system that goes to, with a slide that goes to the base cheek block, and what that does, and it's not shown here, is that allows this particular member right here, this tube, hollow tube with a channel cut out of it, to be able to be rotated. And as it's rotated from this position clockwise, that then deflects the spring. It adds force on the key, and so as the more you rotate it in the clockwise position, the heavier the touch weight will be on the key. In addition to being able to, for the artist to be able to control the weight of the feel of the piano up and down the keyboard, each individual key can be adjusted on its own, and that would be up to the technician to do that. And the reason you'd want to do that is if you'd want to have some variability up and down the keyboard, say from maybe a 52-gram weight at the bass end up to, say, a 48-gram touch weight at the treble end. So it's a pretty flexible system, and it gives a lot of control to being able to adjust the touch weight depending upon the artist's personal preferences. No lead weights. So, in summary, I mean, if you really just look at these two together, I mean, it's almost just kind of shouts at you a little bit. It's very simple. It's doesn't have all the various things going on in here. This is much more massive. Of course, obviously, you have to have lead weights to balance all this out on the other side of the balance rail. But it's simple. This is simple. It's efficient. It's very versatile if you have the touch weight compensation system in it. And, it's durable. You've got a lot of things that, tend to want to have to be replaced over time. I mean, you can even see in this particular case, if I were to zoom in a little bit, this knuckle here is already starting to flatten out. So that's changing all the geometry in the, in the hammer and how it's adjusted, where you really don't have any of that going on here. There's really only 4 adjustments that can be made to the Hickman action. There are the, those 2 screws, you've got the capstan, and then you've got the flat spring that's a part of the touch weight compensation system. And once they're set at the factory or by somebody, they very rarely go out of adjustment. And, maybe about the only time you'd want to even consider making a slight modification is if you have to file the hammers in a significant way. So I hope that clarifies or shows, some of the, the differences between the two actions and some of the advantages for having a system like this. Thank you for watching. Bye-bye.